What is the limit as x approaches infinity of the square root of x plus 1 minus the square root of x? As x approaches infinity, both square root of x plus 1 and the square root of x grows towards infinity without bound. So we have an infinity minus infinity indeterminate form, so we need to do some extra work to find the limit. The answer is multiplying both the numerator and denominator by the conjugate. The expression is not a fraction, but we can think of it as 1, where the denominator is 1. The conjugate of the square root of x plus 1 minus the square root of x is the square root of x plus 1 plus the square root of x. So we need to multiply the expression by the square root of x plus 1 plus the square root of x all over the square root of x plus 1 plus the square root of x. If we use the formula a plus b times a minus b equals a squared minus b squared, the numerator becomes the square root of x plus 1 all squared minus the square root of x all squared when we multiply the expressions in the numerator. The denominator simply becomes the square root of x plus 1 plus the square root of x. The square root and the square cancels out for both terms in the numerator, so the numerator just simplifies to x plus 1 minus x. X plus 1 minus x simplifies to 1, so the entire limit becomes the limit as x approaches infinity of 1 over the square root of x plus 1 plus the square root of x. Both square root of x plus 1 and square root of x tend towards infinity as x approaches infinity, so the entire denominator, square root of x plus 1 plus the square root of x, approaches infinity as x approaches infinity. Since the numerator is a constant and the denominator grows towards infinity without bound, the entire limit is equal to 0. So the limit as x approaches infinity of square root of x plus 1 minus square root of x equals 0.